Okay, hello. We are ready for our geometry notes. This is 4.1. So we're starting a new chapter, and this chapter is all about triangles. You're really going to learn more about triangles than you ever knew existed. Well, on your PowerPoint, first slide, recall that a triangle, and notice this symbol, that's the symbol for triangle, is a polygon with 3 sides. Triangles can be classified by 2 ways: by their angle measures or by their side lengths. And that's what we're going to do here today. We're going to name them or classify them by what their angles are and also by what their side lengths are. What do I mean by that? Well, look at triangle A, B, C, and D. Please note that segment AB, segment BC, and segment AC, there's 1, 2, 3 of them, are the sides of triangle ABC. If I keep going, A, B, and C, now these 3 points are the triangle's vertices. So make sure you have that word memorized, vertices. All right, let's classify them. Triangle classification. By angle measure. Go to a different color so you can see it. By angle measure. It didn't work out too well. I'm going to circle it like that. You need to know what an acute triangle is. We know what an acute angle is, but notice an acute triangle will have 3 acute angles. So if you look at these 3 angles, you see they're all less than 90. That's an acute triangle. We also have what's called an equiangular triangle. And that's where all 3 angles are congruent. That would mean 60, 60, and 60. So we have acute, equiangular. The next one is a right triangle. Notice it has just 1 right angle because it's impossible to have 2 right angles in a triangle. So that's a right triangle. A third one is obtuse. Notice again, it just has 1 obtuse angle. Again, because it would be impossible to have 2 obtuse angles in a triangle. So those 3 vocabulary words are acute, equiangular, right, and obtuse. So let's try some examples. Classify triangle BDC by its angle measures. BDC, let's draw this in here. It's this one right here. Be careful because it's not the entire one. I see an angle of 100 right there, which is obtuse. If it has 1 obtuse angle in it, this means that triangle must be an obtuse triangle. Look at the next one. Classify ABD, which, let me draw that in there, A to B to D, this one right here. Now look at those angle measures. I see a 20 and an 80. Those are all acute. So that would be an acute triangle. Remember, with acute triangles, that's where all 3 angles must be acute. Look at the next one. Now let's do A, B. Oops, that's the same one. This one's what I want. Triangle FHG. Let's draw that in there. F to H to G. FHG. Well, if that's 60 and that's 60, then this top one has to be 60. So they're all three the same. So it's equiangular. Equiangular. They're all 360. So that is a equiangular triangle. So that's all the angle measures. Now let's talk about side length. Look at this first one. Equilateral means all three angles are congruent. Notice these tick marks. All three sides are congruent. I think I said angles. Let me repeat that. It's all three sides are congruent. So vocab word, equilateral. The next one, isosceles. Isosceles is how that's pronounced. At least two congruent sides. So where equilateral is 3, this one, isosceles, is 2. One more vocab word, scalene. Scalene has no congruent sides. Okay. Before we do some examples, remember this thought. When you look at a figure, you cannot assume segments are congruent based on appearance. They must be marked as congruent. For example, if I draw a triangle like this, well, those three sides may look congruent, but you don't know they are congruent until you actually have tick marks. Don't assume. Here's an example. Classify triangle EHF. Let's draw that in there. E to H to F. So that triangle over on the left. My sides are 10 and 12. Well, they're different. Well, this side over here, the vertical side would have to be different as well. Scalene. Every side's different, so it's going to be scalene. Let's try another one. This time, E to H to G. E, H to G. So it's the big triangle. So my side lengths here would be, that's a 12, that's 11, 10 and 4 add up to 14. So everything's different, so that would be scalene as well. Another one, triangle ACD. So ACD, let's draw that in there so we know we're A to C to D, make sure we're looking at the right one. A to C to D. Well, look at these tick marks. If this tick mark is 15, then this over here has to be 15. So my side lengths are 15, 5, and 18. Everything's different, so that's scalene as well. So 3 scalenes in a row. Okay, just about done. I'm going to throw some algebra at you. Find the side lengths of JKL. In other words, solve for x first. So you would write 4x minus 10.7 equals 2x plus 6.3. Why are they equal? It's because of the tick marks. And you would solve that for x, which you can do on your own. The next one, the last slide, is nothing has tick marks. So how do I know anything is congruent? It's because of this word right here. Equilateral means I can go ahead and put my tick marks in. So then just pick 2. It doesn't matter. I'm going to take the 3y minus 4 and pick another one. Doesn't matter because they're all the same. 2y plus 3. And I would solve that for y. And that would give me my side lengths. Okay, we'll practice more of those in class. Just wanted to give you an idea of how to set those up. Hey, thanks for watching.